Hello, my name is Michael Ortega. I'm a research engineer from the Laboratoire d'Informatique de Grenoble in France, and I will tell you about 3D interaction. 3D interaction consists of four main lessons. First, an introduction about 3D interaction. Next, a lesson about depth perception that presents how to display the third dimension. A lesson about interacting with 3D data on the desktop configuration that presents the fundamentals of 3D interaction with a screen, a mouse, and a keyboard. And finally, a lesson about interacting with 3D data on non-standard configurations. That is an introduction of interaction with more immersive environments, like virtual reality environments. The main goals of this course are: first, to understand and acquire fundamentals about 3D interaction techniques and technologies, to be able to estimate the efficiency of an existing solution, and to be able to create efficient 3D interfaces, so well integrated into the context, adapted to the user skills and to the computer's input. Let's start with a short introduction to the domain. We'll see a definition of 3D interaction, its challenges, and its application areas. So what is 3D interaction? 3D interactions, according to Bowman, is human-computer interaction in which the user's tasks are performed directly in a 3D spatial context. In this definition, we can find three main keyword groups. The first one is human-computer interaction. Of course, we are manipulating concepts of HCI. The user, with its own skills, interacts with a computer with its own inputs and performances. The second group of words is spatial context. Here we go beyond the WIMP context. So WIMP means Windows, icon, menus, and pointer for manipulating spatial and three-dimensional data like 3D points, 3D lines, or 3D volumes. The last word is directly. The challenge of 3D interaction is to manipulate directly the 3D data, not with console commands, buttons, or text, but directly selecting, translating, rotating, and scaling the 3D data. The second question is, what is a 3D data? Here we'll see some examples. First, the 3D models, usually called meshes, like the Jerry's head from the Pixar studios, or the house with a red roof. These models are made from three-dimensional points that define lines, that define polygons, usually triangles or quads. This set of polygons defines a set of surfaces that define the object. The polygons can be seen on the head representation, while not on the house, which has a more realistic representation, also called realistic rendering. Here, the objects are empty, so only the surface is defined. Volumetric data are represented here by the skull and the molecules. In that case, the data doesn't define the surface you see, but the displayed surface is computed from the data. For instance, the data that represent the molecules consist of a list of 3D points defining the position of each atom with their characteristics, type, size, color, and a list of links between the atoms. The surface you can see in the image is then computed from these lists. The inside of the skull also have information. Finally, entire worlds can be displayed, like the one you can see in the picture. This scene is a set of objects, and rendering engines are used to simulate the daylight lighting and the realistic textures. The last question is, why 3D interaction? Compared to the classical 2D WIMP interaction, so WIMP means Windows, icon, menu, and pointer, 3D interaction uses the third dimension. Data is not defined in the image plane. Each point has a depth, and most of the time the classical 2D mouse manipulation is not enough. So, interacting with 3D spatial contexts is more than refining 2D interactions. Indeed, 3D data usually depicts the real world. 3D models, like for instance the car here, are displayed in a realistic way using projection techniques that are close to our eye projection. In such a way, 3D interaction should use more natural skills of the user, like the hand gesture presented in this picture. Let's see now the application areas of 3D interaction. One of the most known application areas is design and prototyping. Compared to the traditional prototyping, numerical 3D prototyping presents some advantages, like for example, reducing the prototype cost, facilitating the reusability of the prototype, or facilitating the sharing of the prototype. In this area, the challenge is to help the user on creating and manipulating 3D data. Scientific visualization is dedicated to displaying and manipulating volumetric data, like the scanned skull we saw in the previous slide. 3D interaction is also more and more used in psychiatric treatments. For instance, 3D worlds can be used for treating spider phobias or military rehabilitation. In these cases, the challenge is to create environments with different levels of realism for allowing the user to face its phobias or fears. Training has a similar approach. In these areas, the term immersive environments is used. We'll see this aspect in Lesson 4. Finally, nowadays 3D interaction is more and more used in entertainment environments like games or heritage and tourism. These domains could combine all the challenges presented here: immersive environments for manipulating realistic or not realistic objects in order to entertain or educate the user. In conclusion, I would say that 3D interaction is more and more used in our everyday applications. We'll see now in the following lessons what are the algorithms, the tools, and the technologies for creating applications that allow to interact with 3D data.